Alright, I am going to solve this first problem. Actually, it's problem number 2 right here. Problem number 2 from the potential difference worksheet that we've been working on. This problem says if 6.0 times 10 to the 14th electrons travel from the negative to the positive terminal of a 12-volt battery, how many coulombs of electric charge flow? So that's what we're going to solve first. We're going to do A first. I'll come back and do B. So let's figure out how much of a charge or how many coulombs of electric charge flow. So to do this, we need to go to the sketch pad, and I'll write down the information we need. So we're going to do 2, and this is going to be part A first. Alright, so the first one, it says, the given is this information. It says 6.0 times 10 to the 14th electrons. I'm going to use a little e with the negative sign for electrons. And it says here, on this particular problem, it does say that the voltage is 12 volts. And really, to solve this the first part, to solve for charge, which is what it's asking for, it's asking for Q, or charge, we don't need the voltage on this one, we just need the electrons. In class, we talked about how 1 coulomb of charge is equivalent to 6.25 times 10 to the 18th electrons. Alright, and that's going to be given to you on the test, so do not fear that you won't have this information. You sure will have it. So that's really important. It just tells us that 1 coulomb of charge, it gives us a finite number of electrons, 6.25 times 10 to the 18th electrons. And so here's how I set it up. So I set it up as an equivalent. So I said 1 coulomb of charge, I have 6.25 times 10 to the 18th electrons. Alright, and that has to be equal. So if we change the ratio, so if we change the charge, which is what they're telling us, is that the charge changes, and I'm going to use X and coulombs, X coulombs, if you will, to signify or to tell you that that's what we're looking for, X coulombs, the amount of charge, whatever it is, but it's based on a different number, and it tells us that we have 6.0 times 10 to the 14th electrons. Alright, so in other words, if this charge goes down, there has to be much less electrons. So in this case here, there are much less electrons, so this charge must be going down, right? So there has to be some constant that these are going to be equal to. Here's our constant. We're basing it off of this equivalency here. We cross multiply, and we end up getting this here. It looks like this. We're going to go 6.25 times 10 to the 18 times X. Electrons times X. We'll just leave it as X. And that's going to be equal to, and of course anything times 1 is 1. So it would look like this, 6.0 times 10 to the 14th electrons. There we go. And I'm going to put in parentheses so that we know we're multiplying it by 1 coulomb. Okay, and then all we're going to do is divide now both sides by the number of electrons in 1 coulomb. And it all comes from this side here. Look at that. And this cancels out with the numerator, leaving us with X. And if we do the math, it turns out to be 9.6 times 10 to the negative 5th coulombs coulombs because the electrons cancel out. Use those units and it becomes coulombs. So 9.6 times 10 to the negative fifth, which is a lot less than 1. There we go. It's a lot less than 1 coulomb of charge. It's very, very small. So those electrons make a big deal, but we're also starting off with a tremendous amount of electrons. So I'm going to go ahead and just finish up this video. I'm going to restart a different one for the next problem, which is 2b. So I'll label this one as potential difference 2a.